So in this video, I'm going to take a look at a paper from 2014 from the Journal of Econometric Perspectives by Hal Varian, currently chief economist of Google. And the paper is Big Data, New Tricks for Econometrics. And in the paper, he provides the data set for a number of different data sets. In fact, if you go in and take a look, there's some data for HDMA, a fairly classic data set, but I'm going to take a look at the Titanic. And he has data here for Titanic 3. We'll just take a look at that. This is the passenger list for the full suite of, I think it's the passengers. There's 1,309 passengers, excluding the headings, and it's organized along survived, 1, 0, name of the passenger, the sex of the passenger, the age, then the number of siblings, number of parents or child, so siblings or spouse, parents of child, the ticket number, the fare, which is interesting, the cabin, from where the passengers embarked, I'm not quite sure, boat, body, perhaps where in the ship, and then the destination. Titanic is one of the positive things about the Titanic. Here is everybody's a domain expert to some degree, and understand a little bit the detail that during the maiden voyage the Titanic sunk with the loss of many lives, including many crew lives, which we don't have here. Here we just have purely the passengers, but there was an additional, I think, 700 crew aboard the Titanic, and a large number of those also perished. Okay, so to examine a little bit that data set, then I used Tidyverse which is an RStudio package, so we could take a look at that. Tidyverse, I've already got it installed. Tidyverse. So it's already installed, and it contains a series of different packages, including ggplots, dplyr, stringer, and so on, and many of those are forecasts, and I'll make reference to those as we go through here. So these are powerful visualization data manipulation tools available in R. I'm also going to make use here of, we just copy this and go into the web reference. This is some code here for manipulating data and visualizing passenger data so that we can make some relevant observations here, and we'll see how this works in a moment. Now, the data set that was included here was on train from Kaggle, and so the results that I obtain are going to look a little bit different to this from the Data Science Dojo, and I think the EZD, I think this is Dave Langer, right, from Data Science Dojo. So we're going to make a number of references to code provided by Dave, just to help us understand better what's going on with the survival of the survival data set for Titanic. Okay, now, so the data I'm taking from Hal Varian, but some of the initial code I'm going to take from the Data Science Dojo, right, which is a tremendous resource with a lot of YouTube video clips that can be very, very helpful. Okay, and I advise strongly people to make reference to those. Okay, I do change a little bit the data. I'm going to read in. Okay, so one of the things I've got to do here is set the working directory. I'm going to set it to source. So we're going to read in a file, not Titanic 3, Titanic 4. And what I've done is I've changed if we go back here, the difference between Titanic 3 and Titanic 4 is I changed the headings to have capitals, and that will make the variable names consistent with Dave Langer's variables. So he has capital letters for his headings, for his variables, so I'm going to follow in line with that. And I just changed ever so slightly Titanic 3 to Titanic 4. Maybe I'll just show that. Okay, so here is the Titanic 4 dataset, and I just changed the lowercase to uppercase lettering for the first letter. So that's consistent with Dave Langer's dataset. And okay, so the difference there is it's relatively small. This is from Hal Varian's dataset that he included with his paper, and I'm going to use the format, the headings format suggested by Dave Langer. Okay, so we need to set the working directory, which I've just done, and I then include the library. So we load up the library Tidyverse, and included in the library here would be packages like forcats, ggplots, dplyr, and those are useful for data manipulation, data visualization. We might take a look at that data. We come here to view. We'll open up the RStudio viewer, and it's consistent with the CSV file Titanic 4, right, that we've read in, and we'll note that there are 1,309 observations here. In the train dataset, there's substantially less, about 400 less, maybe 500 less. Okay, so in this dataset we've 1,309. Let's run glimpse, and we've 1,309 observations, so passengers, if you like. And we can summarize, this was a catastrophic event. We might like to summarize the number of people who actually survived. So what's the survival rate? So some have survived over the number of rows. So there's 1,309 rows. Then the sum of survived simply adds up if we take the survived, it's zeros and ones. If it's 1, you survived. If it's 0, you perished. And if we sum the ones divided by the total number of rows, we get the percentage survival rate. So let's just run that. And the survival rate for the Titanic was pretty appalling. Only 38% of passengers survived. I'm also going to save this initial data set, the Titanic dataset, before we put factors, attribute factors. So if we take a glimpse at the P class survived, the sex and a point of embarkation, if we look at where passenger embarked, these are not really characters, these are locations, so we could consider them as being factors. Likewise, P class is not an integer, 1, 2, 3, first class, second class, third class. These are not numbers in the conventional sense. They're really factors. They're discrete points or data points. Survived is binary. It's not discrete. So you either survived or won or you died. And then sex, here, male, female, and we might want to attribute factors here as well, so to that particular categorization. So we don't see them as just being names, like a female. It's not like John, Mary, Tom, William. It's female and male, so they're discrete. It's binary. It's not, for our purposes here, this is not fluid. Okay, so we saved that as a separate file, and then here, and then we come down and it's an identical file, right? So this is the original before we apply factors, and then we set these variables in particular out as factors, okay, to distinguish them either from being numbers or being names. Okay, so we apply that in each instance, and we glimpse again, and you can see now P class is a factor, survived is a factor, 1 is survived, 0 is perished, sex is a factor, and point of departure. So Southampton, Cherbourg, and Q, there's a Q also for Queenstown. Okay, and they're all factors. Okay, and now I apply the code that from the Data Science Dojo, and I like this code a lot because it sets out the survival rate. So let's just take a look. Okay, run, and we're loading in that data Titanic, which has been amended for the factors. And if we look at survival, 1 is survived, 0 is perished. The numbers who perished far exceed the numbers who survived. We can do a table that brings out the number who drowned, 809, and then those who survived, 500. This is on the 1,309 passengers as opposed to the training dataset that's commonly used from Kaggle. Okay, we've done table and then proportions, and again you can see 62% perished, 38% survived. Another little bit of customization relating to labels and so on, maybe to improve this. And you can see survival rate, survived, passenger count. Okay, so second question, what was the survival rate by gender? Here we just have a bar plot and the number of females relative to the number of males. So it's fairly clear that the number of male passengers exceeded the number of female passengers. Now we can incorporate in the proportions who survived. So let's just run that snippet of code, and what we find here is again it's the same plot as before, except we've now filled the proportions who survived related to the proportion or balance who drowned. 0 here means perished or drowned. So females look to have done better, and males, a much more substantial group of males perished on the Titanic, and a smaller number survived. Okay, so that's one of the stark findings here. Okay, third question, what was the survival rate by ticket? So again, we saw that it was first class, second class, and third class, and that would suggest that there could have been different treatments. Let's just probe a little bit that, and using the ggplots here, we're looking at passenger numbers, passenger count, and then the title survival by class. We break down the class by first class, second class, third class, and then we have the numbers who survived and who perished. And again, it would appear first class did substantially better. There's no reference here to gender, just purely broken down by class. Third class seems to have done worst. Fourth question, what was survival rate by class and ticket and gender? So we'll run that. And here we've introduced the facet wrap by class. So we've first class, second class, third class. So we've broken apart the different class designations, and then we examine the survivorship, 1 for surviving, 0 for perishing, and we can see that first class seemed to have done better overall compared to third class, but the most striking thing here in first class compared to third class, most of the females would seem to have survived. Okay, so in the next video we'll continue with the analysis and proceed through the code and the visualization using ggplots.